Fender Amplification, helping musicians to perform better. Welcome to Fender Amplification here in California. My name is Eric. Today on the test bench we have a 1976 Fender Vibrolux Reverb. Customer complaint is that the amplifier has lost its punch, maybe lost some power. So we will take a look at that. Also, I believe that the customer mentioned that there was some noise. This already points to me that this is something going on in the filter pack, so we'll take a look at that right away. Let's begin. And here is a 1976 Vibrolux Reverb. Great condition. This is after the fact. We've already repaired the amplifier, but I wanted to get a front shot, and I'll get a close-up shot of the front panel in the next segment. View of the left speaker, view of the right speaker, or vice versa if the amplifier is facing you, and the shot of the tube chart. Alright, we have just finished testing the electron tubes. All of the electron tubes pass. They all pass. Now it's time to take a quick visual of the filter capacitors, and we can see here that we have an older, unusually unnamed brand of electrolytic capacitors here, and we have this issue. This has been discharged, but you can see that this is not secured because the technician who did this work used the wrong type of electrolytic capacitor. You need something like this, similar to this. Why did they use these here? These are properly done, and then have this section done like this. I'm not sure. This was done, I believe, in 1992. That is, it had been restored in 1992 or serviced in 1992. I don't know what happened here. So we're going to go ahead and replace all of these filter capacitors. 1992, that's 30 odd years. Let's replace those, since the customer was complaining about kind of a weak, kind of a sloppy sound. I dislike that this person did this. This is not great. It's just multiple problems here. I don't normally, most technicians that I see do work on amplifiers do a fantastic job. Most technicians that do amplifier work often come from the military, and they've had a lot of military training in electronics. They seem to be the best at doing this level of technical work. Their work is outstanding, so the work is always amazing. It's rare that you see something like this. I've only seen this twice at this time, and I think in the 30 odd years I've been working in this industry, only seen it twice, so we'll fix that. Just wanted to make a quick note here. This circuit was modified to take a different style of electrolytic capacitor, and some modifications were made. We're bringing this back to the original circuit design from the factory. Positive side all here. We have the negative side here. This is a modified section. This was a modified section. We have the negative jumper together. It goes to a negative wire that's attached to the negative ground point on the other side of this chassis. We have the two positives. These are also jumpered together. We have a wire here that jumpers these two positives together. At the factory, they use a bare wire here. That's how they do it at the factory. There's a high voltage here, so I chose to do insulated wire to bring this back to the original circuit design. Let me explain how this how the flow works here. We have alternating current coming from the wall going to a switch. The power switch goes directly into the rectifier tube. The rectifier tube then takes that alternating current, changes it into direct current. You have a standby switch. When that is engaged, it allows the direct current to flow through this portion. This is the first section of the filtering of the direct current. It moves on to this section. And these three filter capacitors are attached to various preamp and power amp anodes or plates, and they continue to filter the direct current. So that's how that circuit works. We have replaced the filter capacitors. I use the F&T type electrolytic capacitors. We can see that we have two resistors. These are the carbon composition type. You will see many technicians on YouTube replace these with something called a metal oxide resistor. I have found that the carbon composition is the proper resistor for something like this because these are high pulse type high voltage resistors. Carbon composition resistors are used in defibrillators. They use carbon composition resistors because, again, they are used for high pulse voltages. We're looking at the circuit board now. This is the negative voltage power supply here, and we can see that this has not been replaced, so it's a good idea to replace this with a Spragg & Adam type electrolytic capacitor. This is something that I actually really like to see. The technician wrote when he serviced this amplifier, and it looks like it's 4/27/1992. He's got some voltages that he wrote down here as well. This is B positive at 436, and he wrote down his negative bias voltage, negative 46.6. Fantastic. What a great idea. I really do like to see that. It's written in pencil, so that does not reduce the value of the amplifier. So good job, whoever did this part of the restoration or service. Moving further down the circuit board, we're looking at the coupling capacitors coming from the phase inverter going into the power supply. These are the blue types. These don't sound that great. They're not horrible. Fender made Fender installed a brown type capacitor that I really hate. These are better than that, but these are not great. I'm tempted to replace these, at least these two, with Solon type polypropylene capacitors. I'd love to put a paper oil in here. This would probably make it sound really great. Film and foil would be fine as well. We'll look into that as we go further along the circuit. Continuing on to the circuit board in the preamp stage, we are now looking at the electrolytic capacitors here and here. When you have flubbiness in your sound, this is usually the culprit. These need to be replaced. However, these look fairly new for some reason. I don't know why these look so new. Probably because they are new. Maybe somebody came in here and did some work to take care of this section. Now, the customer did complain that there was a kind of flabbiness to the sound. This would most likely be the problem. This looks okay. I'm going to kind of test this out first. Again, we can see coupling capacitors here, the blue type. Technicians out there are well aware of these type of coupling capacitors. Nothing stands out to me at this time. We have some of these capacitors, these picofarad type capacitors replaced. I like this type of capacitor here. I don't know if you can see that here. I'm out of the shot. We have a few of these. 1, 2, 3. Looks like we have 3 of this type of capacitor in here, and I like that brand, so good job whoever did that. Yeah, it looks like maybe we had 3 techs come in here at some point. So I'm going to replace the bias capacitor, electrolytic capacitor. We'll leave these in. I'll go ahead and test everything. We'll do a general service. We will clean the potentiometers, so on and so forth. So let's continue. So here in the bias circuit, we have replaced the electrolytic capacitor with the Spragg atom type capacitor. I really like these electrolytic capacitors for anything in the general circuit. They are expensive compared to other electrolytic capacitors. The capacitors that you can purchase for the filter pack are very expensive compared to other electrolytic capacitors such as the FNT, which I actually really like. But just wanted to point that out. Let's move on to the rest of the circuit. So now we're looking at the coupling capacitors coming from the phase inverter into the output stage. And I replaced the original blue capacitors. That sounded fine. They sounded good. With all the adjustments and replacements that we did, it had a nice big full sound. But I did choose to replace these with a paper and oil capacitor. These are a military type paper and oil capacitors. These are very high quality coupling capacitors. I tried a film and foil as well to compare the sound from the original coupling capacitors by Fender and then the film and foil, and I wound up choosing these paper and oil, which I most often do. Again, I do like to use these in the tone stack as well. Why do these sound so good? Why do they sound fantastic, at least to my ears and to my customers' ears? I'm not sure. What I can say is these capacitors are designed for tube circuits, electron tube circuits. Let me repeat that. These coupling capacitors, these types of capacitors, paper and oil, are designed originally for tube circuits, electron tube circuits. So this might be why these sound really, really good in guitar amplifiers and audio amplifiers, because they're designed for those types of circuits. So that is that. This is something that I gave to my customer for free. He is a working musician, so since his original capacitors were working fine, there was no need to replace these. I just wanted this to sound fantastic for my customer because this amp will be used in many, many recordings. So before I button this up, I did want to point something out here. I put Loctite on all of the fasteners. So the purpose of the Loctite on all the fasteners is because this is a working musician. This musician makes his living making music and playing clubs and probably doing studio work. And if he uses this amplifier, it's going to go through a lot of moving around and banging around and going from a truck to the studio and to his house and so on and so forth. And we want to make sure that we secure all the fasteners so nothing goes awry. So if you are just a home player and you just have this in your living room, this is not necessary. But if you're a touring musician, like this musician most likely is, you want to secure all of the fasteners with Loctite. Alright, so we have replaced the filter capacitors. We brought the voltages up on a variac very slowly. 20 volts, we let it set for 10 to 15 minutes, raise the voltage again to 40 volts, again let that set for a little while, 60 volts, 80 volts, so on and so forth until we reach 117 volts. Bias adjustment is needed because we replaced the bias electrolytic capacitor. I biased the amplifier at negative 47 volts. The plate voltage for each tube was 423 volts, so that's a good ballpark right there. We have now injected a 1 kilohertz sine wave at 1 volt. At 1 volt, I am injecting the voltage into the vibrato stage, input 1, and we're going to raise the volume and take a look at the sine wave, and I'll tell you what I'm looking for. So we're bringing up the volume, and you can see a very nice stable sine wave. That is telling me that the filter capacitors are working as they should. Bringing up the voltage, or bringing up the volume up to 4. Let's back that up a little bit. Right about there. So what I'm looking for here is I'm looking for this crossover distortion here. And that looks good to me. You always want to do a sound test as well, but that seems right about where I'd like to see it. I brought it up to negative 48 and 49. No, I brought it up to negative 47, 48, and it didn't sound as good as getting it balanced. So what I'm trying to do here is I'm trying to balance each side of the output tube. We're looking for symmetry here, not just crossover distortion, but symmetry, and we have some nice symmetry here. That's a nice balance so that the plate voltages or anode voltages are the same, and they were the same. You can check that on pin 3 of the 6L6 tube sockets. So this amplifier is ready to go. So we still have one more test, which is the reverb test. I'm going to omit that test here today because this is a working musician. He needs his amplifier today. He'll pick it up, and he has a gig at 5 o'clock, so starting at 5. So we are going to button this up, get this out to him, but everything's working properly. And I'm very pleased with this. Now I have one more thing I want to point out, and I'll show that to you in the next segment. Let's do that now. I do at this time want to apologize for not having any sound clips for this particular amplifier. Most of my clients come in as working musicians, and there is a need for a fast turnaround, and doing sound clips can take a lot of time. Normally what I do is I just film using the microphone right off the device that I'm using right now to record this very video. However, in the future we will design and create the ability to have better sound clips or have sound clips and then make them somewhat high quality. So please be patient, and I look forward to providing those sound clips to you in the nearest future. Fees are amplification, helping musicians to perform better.